Oh yeah, you're welcome to the third part of this. Yeah, Z-score is quite a dynamic method that we use in machine learning on data science. So we use Z-score for standardization, and you can also use it for outlier detection like this. So basically, let me just write it here. Okay, so Z-score, the formula for Z-score is your particular data point minus the mean, then divided by the standard deviation. So if you calculate the mean and then you calculate the standard deviation, and then you can remove your data from that. So what this will do is that it will transform your data into a different data. And by doing that, the mean of that new data it creates for you will be 0 and the standard deviation will be 1. So I also want to make this to be understandable. What I am trying to say is, let's quickly look at a particular example. So let's say, for example, so let's say this 540, yeah. Okay, I will just, let me say clean data. .head. All right, so we will see how we can use it. If you look at cement, the first data point 540, 266, 388, 266. So let's see how we can transform that with Z-score. Let's do it manually and not use any library. So I would say my data equals to, I'll put this in a list. I will say 540, 266, 380, and 266. This is my original data, right? This should be comma, right? So I can calculate the mean. I will say mean value equals to data dot mean. So the mean of this value let's use true. So if you calculate the mean, let's calculate the mean value equals to mp.mean, and then I can put data, right? So if we look at the mean value will be 398.4. We can similarly calculate the standard deviation. I can say std value equals to mp, which is numpy std, and then I put in my data. If we check that as well, the standard deviation will be 122 plus this. So what we can do now is to look for the Z-score. So let's say the Z-score will be data minus mean value, divided by std value. What I just did was to apply this formula, which is data minus mean minus standard deviation, right? So if we look at this and say Z-score, this is what our Z-score will be. So initially our data that was 540, 266, 380, 266 is now 1.15 minus this, minus this. So you see that the data has been transformed. That is exactly what we're doing in z-score. If we try to look for the mean of this value, so if I say z-score dot mean, for example, you would see that this value is almost 0. The mean will be 0, something great about 10 times raised to the power minus 16. That is 0. And if you do the standard deviation, it will be 1. The standard deviation is almost 1, is 1. So that is what standardization is generally. So the major point, the major thing we are doing here is that we are transforming the data to have mean of 0 and standard deviation of 1. And doing that, all the value that we transform it to, this was the original value and this is what we transformed it to. Now, the values that we transform it to will be between +3 and -3. So now, knowing this, that majority of the value will be between +3 and -3, we can easily say that any value that is above +3 or any value that is below -3 is an outlier. So this is the aspect of which we use for the for the outlier detection. So to make it easy, I will just use the library. I will come in here and import, I will say from SciPy import stats. Okay, and then I can, let me create a different cell. I can say z-score equals to stats dot, I think z underscore score. Let me see. Okay, I think so. Z-score, and then we'll put in our x value. So let's see what the z-score of that data is. Stats, oh, I never ran this cell again. I should have run it again. Okay. Okay, as no z-score, I think this underscore is not there. Okay, yes, the underscore is not there. So now you would see that all of our value, you have 2.5 minus this and all of that. So I can look for the absolute value, mp.absolute. And now all of my data will be between 0 and 3. Yeah, nothing will be over 3. So how I'm going to simply just do this is to say, if we have any number that is greater than 3, so I can say outlier, I can say that outlier equals to z-score greater than 3, right? Dot sum. Outlier. So now if we do this, you will see I have 4, I have 2, I have 10, I have 39. If I do dot sum of this, you see that I have 49 in total. So this is another way of determining your outlier. When we use the IQR method, we discovered about 91 outliers. But now that we are using the z-score, we have only discovered 49 outliers. So depending on the method that you use to determine your outlier, it will depend. It will be the one to determine how many outliers you are able to catch, what you call an outlier and what you don't regard as an outlier. All right. So this is another method of looking for outlier. There is another method, modified z-score and many others like that. But this will be all for the phase 1, and then we can go into the phase 2 where we do some exploratory data analysis. Thank you.